For problem set 8, I had number 12, which states square ABCD is inscribed in a circle of radius 8. Let E and F be the midpoints of AB and BC respectively. The line EF intersects the circle at some point G where F is between E and G. Compute the length of FG. So the first thing you have to do is draw a picture, and once you draw your picture, this is what you get. And what we're trying to find is the length of FG right here. Now the first thing we have to do is find the sides of all of these squares, or all the sides of the square. So what we can do is we can draw a diagonal across the square. And we know that the length of this diagonal here is 16 because it's the diameter of the circle and the radius is 8 and the diameter is simply 2 times the radius. So we can use the Pythagorean theorem to solve this. So we get c squared equals a squared plus b squared. However, since this is a square and both these sides will be equal, we can combine like terms to get 2a squared. So then we get 256 equals 2a squared. And you divide by 2, you get a squared equals 128. So you get a equals the square root of 128. However, you can reduce that to get a equals 8 root 2. So we know that each side of this square is 8 root 2. Now we also know the lengths on each side of this midpoint because the definition of a midpoint is that it divides a length in half. And we can simply divide 8 root 2 by 2 to get that each one of these segments here is 4 root 2 on either side of E. And once again, since it's a square, it'll be the same thing on either side of F. So in order to find this length, first thing I did was I connected G to the center of the square, then I connected E to the center of the square. So now you can see we have a triangle. However, it is not it's not a right triangle, so we can't do Pythagorean theorem to find this whole length and then do another Pythagorean theorem. Okay, so after we connect all these points, what we can do is we can drop a perpendicular from F to the center of the circle. And we can make a right triangle here. And then we can find this length and this length. So we know that this length of the dotted black line here has to be 4 root 2. And that's because when you go from F to the center of the circle, you're taking this height and dividing it by 2. So we know it's 4 root 2. Now we also know that this purple length here is 8, and that's because it goes from the center of the circle to the outside of the circle, and we know that's the radius. So we know that this is 8. So now, although we have this right triangle, we don't have a right triangle over here, so we can't use Pythagorean theorem in order to find FG. However, what we can do is use the law of cosines. Now, since these two legs of this right triangle and this area are equal, we know this is a 45, 45, 90 triangle. So we know that right here is your 90 degrees, and these two angles are 45 degrees. Now, we also know that since this angle is directly across from this angle right here, this little tiny angle right here, and this here, I'll enlarge this triangle. We know that this angle here is also 45 degrees. And now, since we dropped this perpendicular here as well, we know that this is also a right angle. So we know that this angle is 45 and this angle is 90. So we can add those together to get that. Here, I'll make this whole triangle bigger once again. This obtuse triangle here, we can add 45 and 90 to get that this angle right here is 135 degrees. And now that we have an angle and two lengths, we can find FG using the law of cosines. So this here, 8 will be your C, and we'll call this A and this B. So the equation for the law of cosines is C squared equals A squared plus B squared minus 2AB cosine of theta. So we'll have 8 squared equals 4 root 2 squared plus B squared minus 2 times 4 root 2 times B times the cosine of 135 degrees. So you will get 64 equals 32 plus B squared minus 8 root 2B. And we know that the cosine of 135 degrees, according to our unit circle, is negative root 2 over 2. So we can simplify this section out to get 64 equals 32 plus B minus. So we can cross out this 8 and make it a 4 and get rid of this 2 to get 4 times root 2 times negative root 2, which will be plus 8B. And then we can subtract the 32 from this side to get, we can actually bring the 64 over instead. So then we'll have a quadratic equation that is B squared plus 8B minus 32. Now we can't factor this, so what we have to do is put it into the quadratic formula. So we have negative B, which would be negative 8, because we're going by the coefficients, not our actual variable. Plus or minus the square root of B squared, which is 8, minus 4 times A, which is just 1, times C, which is negative 32, over 2 times A, which is just 1. So we get this equals negative 8 plus or minus the square root of 192, once you simplify the inside, over 2. And then we can simplify the square root of 192 to get 8 root 3 over 2. And then we can divide this 2 out to make both of these 4 to get negative 4 plus or minus 4 root 3. So now we have to differentiate between our plus and our minus to figure out which one we will use to get the length of FG. Now we can't subtract, because when you subtract from a negative number, you're just making it a smaller negative number. However, you can add in order to make this quantity positive. So we get that the length of line FG equals negative 4 plus 4 root 3.